Today we're going to review some least common multiples. We really need to practice this. When I looked over your class assignments from last week, it looks like a lot of students are really struggling with this idea, especially working from trees with bigger numbers. So it's always safer to use factor trees in this situation. That's why I've modeled one here for you, because if the numbers get too big, it's easy to miss some factors that maybe we're not as familiar with on a T-chart, whereas we can catch them with our prime factorizations. You should have a name, first and last, what color hour you are, either yellow, green, or blue, and also today's date. These are notes. This is really to give you some good examples. Instead of moving on today, we're really going to do a quick review to make sure that everybody's okay with this concept, because we're testing over not only least common multiples, but everything in Chapter 1 in just a week. If you notice, I gave you some steps to follow to find LCMs, or least common multiples. So we're going to follow the steps. Step 1, make a factor tree. Oh, and if I look back at my example, I see that there are already two factor trees shown. So we're going to break both of these down. Remember, we're trying to get to some prime numbers here. So 66, well, I know that's the same as 6 times 11. And if you think back, we would say that 6 is composite, so I can't circle it. But 11 is prime, so I will circle it, meaning only 1 times 11 will work. 6 could be broken down again into 2 times 3, and both of those numbers are prime, so we'll circle them both. It looks like our tree for 66 is done. I could write out 66 is the same as 2 times 3 times 11, and I could do a double check. 2 times 3 is 6, and 6 times 11, well, yep, that gets me 66. 33, let's break it down. It looks like 3 times 11 should work. Well, 3 is prime if you remember, and so is 11. This tree is actually already done. So 33 is the same as 3 times 11 if I put those factors in order. Well, step 1, our trees are done. Step 2, order the factorizations. Oh, I already kind of did that. With all good trees, we chop them down, or at least line them up. Step 3 says circle any pairs. Remember, that means any factor from the factorizations that match. So 33 and 66 both share a 3. 11 is also in both of their factorizations. So next, we circled our pairs. It says record each pair only once to find the greatest common factor. So we start by finding the greatest common factor, which we're familiar with, before we find the least common multiple. We take out something that they have in common first. So here we would say the greatest common factor is the same as, well, one group of 3's and one group of 11's. And because these are factorizations, we're going to use multiplication to show that step. Well, 3 times 11 is 33. Well, I just found the greatest common factor, also known as the biggest number that will divide nicely into both 33 and 66. 33 is a factor, or the biggest factor of both. Too bad I'm not looking for greatest common factors today. I need to take this one step farther. So step 5, multiply the greatest common factor times the extras to find the LCM, or the least common multiple. So here I would say the LCM is really the same as the greatest common factor times any extras. And I always like to write this out so that I remember this step. So I take a minute and I write least common multiple is the same as the greatest common factor times its extras, meaning its extra factors and its factorization. So the GCF we found was 33. And the extras that I see would be sitting right up here. Well, there is an extra factor in 66. It looks like it's a 2. There are no extras in 33. And if I needed to factor this out for some reason, I could use a 1, meaning 3 times 11 times 1 would never change its value, but that's not really needed for a least common multiple. Well, 33 times 2 is actually 66. The LCM of these two numbers, 66 and 33, is actually 66. And we just proved it using our factor trees, finding our pairs, pulling out our greatest common factor, and then multiplying by the extras to get to a LCM, or least common multiple. We're going to try that again with the next two. In fact, maybe if you have a guest teacher here today, this is something that you would try on your own for a minute. So maybe you'll put this video on a quick pause so that students can work, and then come back and do some checking in just a moment. I'm guessing you might be back, or maybe you decided not to pause the video.
Please excuse the interruption. All cross-country members, please meet in the cement hallway in the 6th grade building after school today. Again, all cross-country, please meet in the cement hallway of the 6th grade building after school today. Thank you.
Too bad your teacher doesn't know how to edit out an announcement overhead. So we'll carry on. With that, we need a tree for 36 and 24. Well, 36 could be 6 times 6. And if you notice, 6s are composite, so we'll break them both down again. 2 times 3 would work for both of these. And 2s and 3s are all prime. 24, we need to break this into some factors. Well, let's see. I think 3 times 8 will work. Yep, 3 times 8 is on my multiplication chart. 3 times 8 is 24. 3 is prime, but 8 is composite. We need to break it down again. 4 times 2 is good. 2s are prime, but 4s are not. 4 could be written as 2 times 2. I better circle both of these. They're both prime. If you notice, all of the branches of my trees are done. So step 1, I made my factor trees. Step 2, order the factorizations. That really means take them and write them in a sequential order. So from 36, I have a couple of 2s, and I have a couple of 3s. You want to show some multiplication here because these are called factorizations. And in fact, 2 times 2 is 4, and 3 times 3 is 9, 4 times 9 is 36. It checks out with multiplication. Let's do the same. Let's order our factorization for 24. Looks like we have more 2s, 1, 2, 3 of them, and a 3. It's okay to cross these off your tree if you'd like, to say, oh, I've got 1, 2, 3 2s, and a 3 in my factorization. If you look back at your steps, it says circle any pairs. So we're on step 3 here. Circle any pairs. Well, I want the numbers to appear in both 36 and 24. So I notice they both have a 2. They both have another 2. How about here? They both have a 3. Or you could circle these 3s instead. I think we're ready. You are helping me find the greatest common factor. Those pairs really get me to the biggest number that I could divide into both of these. So, one pair of 2s, record it once. Another pair of 2s, record it once. Another pair, but it's a pair of 3s, record it once. Remember, we get to multiply here. What is 2 times 2? 4. What's 4 times 3? 12. The greatest common factor is 12, meaning they both share a 12 in their factor list. That's great, but I don't want the GCF today. I want the LCM. So remember what we said. LCM is always the same as taking the greatest common factor, what they have in common, times their extras, the things that are different. So to do this, I'm kind of running out of space here, so this isn't ideal because it's looking like Dr. Seuss. But here we go. I'm going to take my GCF times my extras. And the GCF was 12. The extra factors that I didn't circle or didn't have pairs would be a 3 and a 2. If I look over here, there's an extra 3 and an extra 2. I need to multiply by those. Well, if I were to simplify this, I know that 3 times 2 is 6, and 6 times 12 is 72. It looks like my LCM of both numbers is 72. Okay, we need to try again. We have a third example here. So again, maybe you've already tried this on your own, and maybe you're turning this back on to see how it went for yourself. If you make different trees than I did, as long as you end up with the same prime factorizations, you're good to go. 2 trees, one for 70 and one for 42. Well, 70 is the same as 7 times 10, and 7s are prime. 10 can be broken down into 2 times 5, and both of those are prime. This tree is done. 42. Well, let's see here. I know it looks even. It ends in a 2. Half of 40 is 20, and half of 2 is 1. Looks like 2 times 21 will work. I know 2 is prime. 21, I think it can be broken down, and you can look at your multiplication chart to find, yep, there it is, 3 times 7. Both of these numbers are prime, meaning only 1 times 3 can get me 3, and only 1 times 7 can get me 7. They only have 2 factors. Now that all of our prime numbers on our factor trees are circled, it says step 2, order the factorizations. Well, 70 is the same as 2 times 5 times 7, and notice I like to go from least to greatest in order. 42 is really the same as 2 times 3 times 7. There, my factorizations are ordered. There's a good sequence to them. Circle any pairs, step 3. Well, I notice they both share a 2, and they both share a 7. Step 4, record each pair only once to find the greatest common factor. Greatest common factor. Well, I have a pair of 2's, record it. And I have a pair of 7's, record that also. What is 2 times 7? 14. That really means the biggest number that divides into both 70 and 42 is 14. 14 is a factor of both. Too bad I'm not looking for the greatest common factor. I'm looking for the least common multiple. So I take what they have in common, known as their greatest common factor. Oops, and I was writing the word and, but really we need to multiply times its extras. So let's see here. The greatest common factor was really 14. I found that a minute ago. And the things that are unlike or different, I need to multiply by. There's an extra 5 and an extra 3 in its factorization. This one looks a little bit trickier. The numbers are getting a little bit bigger. Well, 5 times 14. 5 times 10 is 50. 5 times 4 is 20 more. 50 and 20 make 70. 70. 70 times 3. We're getting there. Well, I know 3 times 7 is 21, so 3 times 70 should be 210. The LCM of these two numbers is 210. To be honest, this is a much safer method than trying to do multiples of two numbers that I'm not really familiar with. So this strategy to make trees, find pairs, pull out a greatest common factor, and then multiply by those things that are different or those extra factors will get me there every time. So I don't have to worry about as many errors in a multiple list. It's really time for you to give this a try. If you notice on the back of your paper, you have something that looks like this. You're going to be moving around today a little bit, working in partners. You're going to choose one of our LCM cards and you're going to record what number the card is. So let's pretend you're on card number 80. By the way, they don't go that high, but if they did. You would also have to show me all of your work. That's why it says show all work. So you would take the two numbers on the card that it says find the LCM of 45 and 50. Well, remember, we get to follow our steps from a minute ago, so you can just break out these rules just like we had a second ago and follow exactly what we did. I first need 2 trees. When I'm done with 2 trees, I need to order my factorization. I need to circle any pairs. I find the greatest common factor, and then I multiply that by any extras to find the least common multiple, meaning the first multiple that they would share in a list. It's your turn to give this a try. Again, remember to record what card number you're on, build trees, follow these steps, and find us the LCM each time.